So we are today going to visualize how a gradient descent algorithm can be visualized using a simple Java console program. Okay, so gradient descent, as you all know that it is a machine learning library or machine learning algorithm. This algorithm can be used to calculate that minimum of a function or which is used to calculate the loss of a function. A function is any algebraic equation. So, for example, f of x is equal to x squared plus y squared, or f of x is equal to s squared plus 2x, etc., etc., etc. So, anything that is depending upon this situation. So, in this example, or in this video, we are going to demonstrate how we can visualize it. This is a simple Java console program. Okay, so let us just start this code and see what we are going to see first. So this is the output of this console application. Okay. Now we will uh, we will do the walkthrough of this code and try to understand better. Basically, this is the function. Our function, loss function is f of x is equal to x squared. That is when x is changing, the output will be is exponentially it will change. And the learning rate is 0.01. The current value of x or the starting value of x is 10. That is the starting point. Now we have 60 iterations. So what we are going to achieve here is in the 60 iterations how these particular values or how this gradient is going to reach zero. How fast it is going to reach to zero. This is what we are going to uh, experiment it or visualize it. So let us uh, just walk through this demo. Let us just check the example of this demo application or demo code. Uh, for that, what we are going to do is we are displaying in the four column. Okay, first column is iteration, that is number of steps it is required to reach the value to zero. It is not always necessary that it should attain zero, but as close as to zero. That is okay. Then the second column is the x, the value of x. Third column is f of x. I mean that is the loss function. Then third one is the gradient or its slope, whatever you call it. Now we are starting the iteration from zero. Then in this case, we are calculating the f of x. I mean the loss function is x into x. The default value of x is this one, 10. Okay. So we are getting f of x is x into x, which is 100. With this value, we are calculating the gradient. Gradient means 2x, 2x always, because the loss function is x squared. So its gradient is 2x, its derivative basically. So 2 into 10 it is 20. Now we are going to display this in a tabular column. That we are going to see it here, something like this. So iteration, then x, then loss function, then it is gradient. So these are the four columns. We are going to print it on the console. So the second column is the x, third column is the loss function, third column is the gradient. So as you can see in the first iteration, when the x is 10, f of x is 100. Then gradient is 20 because 2 into 10, 20. Next time, we are calculating the x again. How we are calculating this x? We are subtracting 10 minus this learning rate. The learning rate is 0.1, which is constant, into the gradient. So the previous value of gradient is 20. So 20 into 0.1. Okay, so this will yield 8. Okay, so the value of this is going to be uh, 8. Then this value we are going to apply again for the loss function. So 8 into 8, 64. So f of x is equal to 64. X is 8. Then gradient is 2 into x, which is 16. The gradient is try to be reduced. You can see that the second iteration, the gradient is reduced. So the x is 8 here. Then again, uh, x is equal to x minus learning rate into gradient. Gradient in this case 16, 16 into 0.1, then whatever value it is, then it will print the value as 6.4. This is the third value of x. When the third step or when the third iteration, x has become 6.4, then again we are calling the loss function, which is x into x, sorry, and calculating the gradient once again, which is 2 into x. So 2 into 6.4, which will give you the gradient. So as you can see that we are just climbing the step down from a hill. Then finally we are reaching to the terrain. So that is what actually happens in this case as well. The value of the gradient, you can see, will be trying to reduce it as the steps increases. Then if you move further down, if you go further down somewhat around 40 to 50 steps, you can see that the value is getting 0, close to 0, 0.009, 0.007, 0.006, and so on. Finally, the value is set to 0 here. So by the time it reaches 60 iteration, you can see that all the values are set to 0. This is the way this particular gradient function, I mean this loss function, is reaching to 0, and this way we can visualize how this function, or how this loss function is reaching to 0. Here, one thing that you need to understand here is learning rate. To select the learning rate, it is very important to understand the loss function. Okay, if you change this loss function to something else, 0.01, and see what happens. See, when we change the loss function, sorry, the learning rate to 0.01, you can see that with the same iterations or steps, it is not reaching to 0. It is somewhere stuck at 5.995. So it is very important to select the learning rate based on the loss function. That is very important. If we are changing the learning rate, then it you might be required to change the iterations. So in this case, 60 is not enough. With the 60 steps, it is not going to learn it. It is not going to get the maximum loss from loss. Okay. So for that, you need to increase this value to something, say, let us say 120 or 100. See what is going to happen. Now, in the with the 100 steps, still it is 2.6 only. So we are making it to 120. No, it is not reaching to 0. So we will make it to 150 and see. Yeah, 150, then 180. Let us see. No, it is still. So we need 280. I don't know. Yeah. So we need so many steps. Let's make it a 380 in this case. See whether we are getting it. Yeah. Uh, if if we change the learning rate, then you can see that we need lot of iterations to get the gradient 0. So that is the importance of the learning rate. So the Selecting the learning rate must be very careful. It is based on the loss function that you are going to use it. So this is the way we can visualize a gradient descent algorithm. Okay, thank you.